In this next video, we're going to introduce ions and ionic compounds. When we were talking about elemental symbols and subatomic particles, I noted that when we had a neutral compound, the number of protons would always equal the number of electrons. But in ions, they tend to gain or lose electrons. To be like the closest noble gas. To form a more stable element is why they lose or gain electrons, but they do not have the same number of protons and electrons, and they would result with a charge. So when we define ions, when atoms lose electrons, these are called cations. They are going to be positively charged. And these are formed by elements that are on the left side of the periodic table, so by metals. Anions, on the other hand, these are going to be negatively charged and are formed by the elements on the right side of the periodic table, so those nonmetals above the staircase. And then when a metal and a nonmetal combine, most commonly, something from the left and the right side of the periodic table, we get ionic compounds. And they form what we call ionic bonds, which are these strong forces of attraction between a positive and a negatively charged element. So in sodium chloride's case, sodium metal becomes a +1 ion. A chloride atom becomes a -1 charged atom, and then they are attracted to one another and they form this ionic compound called sodium chloride, which you may be familiar with. NaCl solid is table salt. So many of these ionic compounds form crystalline structures, and in general, we refer to a combination of a positive and negative ion as a salt. So magnesium fluoride, calcium bromide, these will all be salts in general. So if we continue down to the periodic table here, we can actually predict what ionic charges will result for different elements based on what group they're in. So group 1 elements, these will always form +1 ions. And notice hydrogen is over here. Hydrogen could also form a -1 ion, but for our purposes, we're only going to see it in the +1 form this semester. But the remainder of the group 1 elements here, we can see it's easiest to lose 1 electron, become a +1 charged cation, to gain stability. If you remember, I stated that all the elements that become cations or anions are either losing or gaining electrons to have a more stable form and look like this column here, the noble gases. So anybody in group 7 here would gain 1 electron and become a -1, like fluorine and chlorine and bromine and iodine. They all become a -1 ion. And then we can see similarly next to the +1 in group 1, group 2 will lose 2 electrons to become +2. So whatever the easiest approach is to become like a noble gas, either gaining 1 or 2 electrons. Rarely we see, group 5 here would gain 3 electrons, like nitrogen. And it's all to gain stability. And then we can see these metals and nonmetals would combine and become ionic compounds. So let's see if we can complete exercise 6 here and determine whether or not we expect the compound that would result from these elements to be ionic. So a metal with a nonmetal, and a molecular compound would be 2 nonmetals. So we'll quickly go through A through H here. So nitrogen and oxygen in N2O, these are all nonmetals. So we expect a molecular compound. Next, we have in B, sodium and oxygen. So that's a metal and a nonmetal. So we expect an ionic compound. Calcium and chlorine, we get calcium chloride, which would be a metal and nonmetal, an ionic compound. Next, we have sulfur and fluorine. So sulfur tetrafluoride is a molecular compound because they're all nonmetals. In the second row here, we have carbon and bromium. So carbon and bromine, when they combine, we're going to get a molecular compound because all nonmetals. Then we have iron, which is a metal, and sulfur. So iron sulfide here is ionic. Next, we have all nonmetals again, phosphorus and oxygen, so a molecular compound. And last, we have lead, which is a metal, and fluorine, a nonmetal. So you may have guessed, we have another ionic compound. So we'll continue in the next video and determine how we can figure out what subscripts would be in our molecular formulas.